If you've never heard of JPCap, or this is your first time taking a look at it, you might be wondering exactly what it is. JPCap is an open source network packet capture library based on the libpcap and wimpcap libraries that you can use with Java to capture and display network traffic on Linux, Windows, and Macintosh computers. JPCap captures Ethernet, TCP, UDP, IP version 4, IP version 6, ARP, RARP, and ICMP version 4 packets, and analyzes each packet's header and data payload. So what about using JPCap? There are several dependencies and requirements you will need to meet before being able to use JPCap on your Java projects. To write Java applications using JPCap, you will need to: first, download and install WinPcap. A link to WinPcap currently is www.wimpcap.org install default HTML. These links may change, so if you need to, use your good friend Google to find these things. Second, after you've downloaded WinPcap, you need to download and install JPCap. The current link at the time of this video is netresearch.ics.uci.edu kfujii jpcap.index.html. Again, if for some reason these links change, simply Google for these items. The default install routine for JPCap may not put things in the right place for your particular development environment. Therefore, after installing JPCap to extract the files, find jpcap.dll and jpcap.jar on your system. Then, you need to copy jpcap.dll into the Java Runtime Environment directory with the bin subdirectory or the JRE libext x86 subdirectory, depending on your system's architecture. Next, copy the jpcap.jar file into the Java Runtime Environment directory and the lib and ext subdirectories. Or, copy the jpcap jar file into the jdk directory, JRE, lib, ext subdirectories. Note, if you have the 64-bit JDK and JRE, and then download the 32-bit version, you will need to copy the files to that platform's JDK and JRE folders as well. 6. If you are using the 64-bit JDK and JRE, download and use the 32-bit JDK and JRE. If using NetBeans, you can add it as an additional platform and select between 32 and 64-bit versions when necessary. 7. If using NetBeans, right-click on your project properties and select Libraries, then select the 32-bit JDK from the Java Platform drop-down list. 8. Click the Add Jar Folder button under Project Properties and Libraries and add the jpcap.jar file to your project. 9. When running applications that use JPCap, you need root privileges in Linux and administrative privileges in Windows. You'll get runtime errors if you attempt to use JPCap without the appropriate privileges. If using NetBeans in Windows, you must right-click and choose Run as Administrator. In Linux, you can hit Alt F2 and type gksudo netbeans. Finally, if you've done all these things and you remember to run things with administrative or root privileges, you're all done. Now you can start coding projects using JPCap. Here are some JPCap classes we'll be using. The first is the Packet class. It's a JPCap class that is instantiated for each packet captured and used to access that packet's field information and data. The second is JPCaptor, and it's a JPCap class with many methods for capturing and filtering packets. Here are some JPCap functions we'll be using. GetDeviceList, which returns an array of network interface objects for each network interface on the specified host. OpenDevice, which opens the specified network device. Its arguments are 1. The network interface to open, 2. The maximum number of bytes captured at once, 3. Whether or not to be in promiscuous mode, which is true or false, it's Boolean, and 4. The timeout for the capture. 3. setFilter, which sets port filter options, and it takes 2 arguments, 1. A string of the ports to filter, and 2. Whether or not to optimize, true or false. The next 2 methods are similar, loopPacket and processPacket. LoopPacket captures packets for a specified number of iterations. It takes 2 arguments, 1. The number of captures, where -1 would be infinite, and 2. A new instance of a class that implements the packet receiver interface. It ignores timeout and does not support non-blocking mode. ProcessPacket also captures packets for the specified number of iterations, takes 2 arguments, 1. The number of captures, where -1 is infinite, and 2. An instance of a class that implements the packet receiver interface. However, it accepts timeout and supports non-blocking mode, which means it returns immediately when there's nothing to capture. Then there's getPacket, which simply captures a single packet. There's breakLoop, which forces loopPacket and processPacket to stop looping and return. And there's setPacket read timeout, which sets the timeout value, and getPacket read timeout, which retrieves the timeout value. Let's take a look at an example. As an example, I've written a simple packet capturing application, and I'm going to call it PacketPirate. And this is just using Jpcap and just showing some of the Jpcap classes and functions that you can use with Java, as network tools or for examining and doing things with network traffic. So this is the graphical user interface or the GUI, and I'll just kind of scroll. I'm going to go through the code in detail in a minute, but I'm just kind of giving you a glance. Okay, so that's 683, 684 lines. Not too big there, not too large. This is a standalone interface if you created it in a text editor, if you weren't using NetBeans. An additional example, I also did this version here, which is it's also the interface, but this is just done with the NetBeans form design tool. I used a JFrame form. Okay. So either way, but just in case you're using a text editor, I'm going to kind of go off this version here. All right, but that's just the graphical interface, and then some functions for capturing traffic. All right, so we'll talk about the structure. I have to do this as a threaded process because if I don't, it won't work properly with the JFrame graphical interface. In other words, while I'm capturing traffic, if I do all this without multi-threading, it's not going to refresh and display properly in the interface, and the user won't be able to stop capturing or interact with the JFrame, until the capturing is done. So because of that, I have this, and this is just a derivative of a swing worker class thread. The same one you can download off Sun's website, or I guess now Oracle's website. But swing worker threads, I like to use this. They work very well when you're using a graphical interface, and you want to do a multi-threaded, create a multi-threaded application where you can do several things at once, including allow the user to interact with the graphical interface while other things are going on. And in addition, I just have this very simple class here. And if you go to the JPCap website, you'll see that this is a technique that he recommends using, or that the developers recommend using. And in this case, you're going to implement the interface packet receiver, which means you have to include the required abstract method receivePacket. And I'm just displaying the packet here, and in this case, it's in a text area. Text area on my JFrame interface. Okay. And then last but not least, I have this, and this is just code that I adapted. In some of the previous tutorials, we were talking about network interfaces in Java and the network interface class. And this is just that same application pretty much. I just included it as, sort of you click the info button and you can get information on different interfaces. All right, so that's sort of just an overview, and we'll go into detail in a minute. That's just the basic class structure, okay? That's just the way things work. Just as an example, I'll show you, both interfaces here. And here's the NetBeans designed interface either way, but if I click on it and run it, all right, here's my, just my basic JFrame. And first, I need to click list to show me the interfaces on the host. So in this case, 0 through 4 is how they're indexed, and the one I'm interested in is where I have this class B IP address here, 4. So I'm going to put 4 in and select it. And once I've selected the interface, the rest of the buttons are enabled. And I'm not going to do any filtering. I'm just going to do a basic capture, which will be like everything. It'll listen for everything. So I'm going to click capture. And it's going to just start capturing packets. Okay. And then I'll click stop. All right. So you can see it's just gathering information, packets out on the network there. The source and destination IPs, and the protocols being used, UDP, TCP, ARP. And then if I want, I can save the file. I could load the file. And there's other basic functionality. This is just a little info screen here, in which case we can go through all the different interfaces. Alright, and just get information on host interfaces and things. Okay. So that's the NetBeans interface. This is an example of the graphical interface if you were to create this in Notepad or a text editor. or Eclipse or something like that. But without the NetBeans form design tool, in this case, I've just declared all my GUI globals up here. And then I wrote a function build GUI, which takes care of position and everything. I'm using absolute layout, so layout manager set to null. And then the event handlers down here, and then just the code for filtering and capturing packets and things is right here. Alright, so, and to see how that looks, it's pretty much the same. And again, I would select the interface. Alright, class B address, that's the one I want there, 4. And then hit capture, and I'll just start capturing traffic. To start out analyzing this project, obviously the first thing you're going to want to do is set up and install Jpcap. So get your library and the jar files in the right place. Also, in project properties, you want to make sure, here I have a hybrid system. I go back and forth between 64-bit and 32-bit, so I'm using a 32-bit JDK. And there's jpcap.jar. I want to add that to my project. So I want to take care of those preliminaries. And then these are the imports I need. Obviously, Swing and the Abstract Windows Toolkit for my graphical interface components, my J components. Obviously, I need auth event to implement action listener, right? The event handling interface action listener. And then I need JPCap. I've got to import that for all my JPCap classes and functions and objects. And then IO here for basic file access, just so that they can, save capture data to a file and load capture data from a file. All right, so we've got our imports there. Then inside the class of our graphical interface, we have a couple of globals here that aren't related to the GUI. In this case, we have an array of network interface objects, which we'll use when we get the device list later. We have an instance of JPCaptor called cap, which we'll build and use later. We have a PKPirate capture thread called Captain, which is really just a derivative of a Swing worker thread. That's this class here, remember, but it's pretty much the old Swing worker thread, which I like to use with interfaces when I'm doing a multi-threaded project. Then we have index and counter, just 2 integers, and Boolean capture state, which is starts out as false. And we'll use this to turn things on and off or toggle with our capture thread. And the reason is because like the stop method was deprecated, and they prefer that you use interrupt or wait or something else when you're waiting on a thread. All right, so those globals are not necessarily related to the interface, but they're globals. There they are, they're declared. Then we get down to our graphical user interface globals. And obviously we need a JFrame. That's our main window, and this is the title right here. We're building a new JFrame. This has to be public and static. It's the main big text area that you saw when I ran the program. And the reason it has to be public and static is because this class here, PKPirate packet contents, it prints or displays the contents of the packet. And it has to access that outside the class. And the only other way I could do this without making it public and static is I could rewrite the constructor to take a pointer to a JFrame, and then I could pass into this pointer when I built an instance of this. And in that fashion or in that way, I could do this without making it public and static. But what the heck? It's just easier if I make it public and static. I don't have to worry about passing into this pointer and rewriting the constructor. But if you want to do it that way, please do it that way. But that's the only reason that I did that with the text area. Everything else could be private or protected or whatever your preference is. Okay, and then all of the other components. In this case, a scroll pane. So we can set our scroll pane, policies. In this case, there's no horizontal, but there's always a vertical scroll bar. And then we add that scroll pane. That'll take care of, applying those settings to our text area TA output. 2 button groups for our radio buttons. One on whether we disable or enable the filter, and the other one on if it is enabled, which port we're going to filter on. Got some J buttons here. You saw those on the forum for all of the different functions, what they do. Here's our radio buttons here, and you saw those on the forum. So these are for selecting all of the different ports and things on the forum. All right, and then we have some J labels, just to kind of label things on the graphical interface, and you saw those. And here are the 2 text fields that you saw for selecting the interface and selecting the port if they choose the special port radio button. So those are all the globals. You've seen them, you know what they do. So now what happens? Well, remember when you run a program, the very first thing that happens is the main method gets called. Alright? So when the main method gets called, what happens? This JFrame is going to build an instance of itself. New PKPirate GUI. And then once it does that, it's going to call the constructor, or its constructor, which will then turn around and call the methods build GUI and disable buttons. So let's take a look at the first function being called from the constructor once the JFrame builds itself in the main method. And all build GUI does is simply set up the graphical interface. It's just basically shell code, or like, kind of Java boilerplate code for a graphical interface. There's no real network or JPCap action going on here, but I'll still go over it so you can see. In this case, main window, remember that was our JFrame. So all these globals that we declared up here for our GUI, we're just going to configure them here in build GUI. We set the size and the location of the JFrame. We set the default close operation to exit on close. We have to get the content pane, and I'm setting the layout to null because I'm going to use absolute positioning. In other words, I'm going to specify the x and y coordinate of every component and the width and height using the setBounds method instead of using a layout manager like flow layout or border layout or card layout. I'm not a big layout manager fan, but there are advantages and disadvantages to absolute positioning, but it's just kind of my preference. So, here's our text area, so it's not going to be editable, but they'll be able to use it to display the contents of packets that are being captured. We're setting the font, the foreground, and I want it to be multi-line, so I'm setting line wrap to be true there with the scroll bar. And then with our scroll pane, we're setting the horizontal scroll bar. I hate horizontal scroll bars. Maybe you don't. I do, so I'm never. And the vertical scroll bar as always, so it'll always appear on the right there. And then notice that when you use a scroll pane, we don't add the text area, but we add the scroll pane to the window. And we add the text area to the scroll pane with set viewport view. And then here we turn around and we add the scroll pane and not the text area to the JFrame, to the main window. Okay. Now all of these are buttons here, and I'll go through them real quick. We're just setting the background, the foreground, the margin. And here for each button we're adding action listener, and this is one of 100 different ways to do this. And I try to do it a different way in each project, not to annoy you, but just so you can see that there is more than one way to do something. There's like 100 different ways to do something, and maybe some ways are easier or better than others. I don't know, but so we're just adding action listener, but without having to implement it and put it in a single action perform method. So for each button we're going to do this. We'll add action performed, and then the way I like to do it, maybe this is kind of an MFC influence with Visual Studio, but I just like to pass the buck to another function, or map it out. I mean, you could type the code right in here in these braces, the event handling code, but each one of these is just going to map the event handling responsibility to a separate function. And for me, that's easier. I like doing it that way. It makes it easy to modify event behavior when I click on a certain button. I don't have to worry about fishing through this code. I have a separate function dedicated for each one. Alright, and then I'm just getting the content pane, I'm adding the button, I'm using setBounds, and I set the x coordinate. Remember, x goes from left to right, the y coordinate, that goes from up to down, and then the width and the height. And I do that for each one, so I'm not going to, to save time, videos probably are going to be too long here, but to save time I won't go over each button, but knowing what you know now, you can see that I'm just doing the same thing for all these buttons. The only thing that's different is the XY position and the event handler. I have a different function for each button that I'm calling. Okay, so you can see that all the way down. There's all my buttons being added. Okay, and then when I get down here, now I'm going to add my radio buttons. And remember that in order for radio buttons to be set so that you can only click on one at a time, they have to be added to a button group. And that's, remember, I had two button groups: button filter, enable, disable. So I'm going to add the enable and the disable buttons to that, and that way you can only click on one or the other. And then the rest of my radio buttons were for selecting different ports. And my button group was BG ports. Okay, and I'm going to add all the rest of those to that button group. So you can see how that works. And then I'm just setting the font, and I'm adding the radio button. And again, always set bounds, since it's absolute positioning, with the X and the Y and the width and the height. Okay, so if you look all the way down, I'll scroll slowly so you can pause if you need to. There's all my radio buttons. Okay, and still we haven't done anything yet with capturing traffic or networking, or this is just the code to build the JFrame, to build the graphical interface. Okay, and then finally down here, we are adding some J labels and configuring them, just setting the font, foreground, centering the text in this case, and then adding it and setting the X and the Y and the width and the height. Same thing, all the way down, including our text fields. And then finally, to get our JFrame to pop up and display, to make it active, we call setVisible on our JFrame, which remember our global was called main window. And so this takes care of making our graphical interface display, okay? And then the next function that we called up here was disable buttons, but before I go over that, I'm going to go through my event code real quick and I'll show you how I map things out to different buttons, right? Remember disable buttons was called there. Okay, well right after I build the graphical interface, I have all these functions that have defined the event code. When a certain event is heard or triggered, then this is the event code that goes and does one thing or another. So if it's capture, here's the event handler. If it's stop, here's the event handler. Select, list, filter, info, save, load, about, help, exit, enable, and disable. Don't need this for all the radio buttons, just those two because I'm just changing the text here. Alright. Instead, when you click the select button, it uses, it will see which radio button is selected or checked and do something different. Alright, so I'm going to go over that in more detail, but I just wanted to give you an overview of, that is what's happening up here. Alright, in each of these categories where I'm building the GUI. So let's go back and kind of look at the very last thing that happened after our JFrame loaded, right? And the constructor was called, we built the JFrame. It called disable buttons. Why? Well, again, I'll show you what that looks like. This pops up here. And why? Well, we can't allow them to capture, or we can't allow them to do certain things until they've selected a valid interface. And we want to avoid null objects or null pointer exceptions, things like that. So because of that, all these buttons are disabled here. You'll notice that, right? And let me go here, and we'll go to disable buttons, and I'll, that's just a couple of simple commands there. So just using the set enabled method to disable all the buttons that are kind of dangerous for the player to use or the user to use until they've selected an interface. Then once they've done that, we'll enable the buttons. So again, what happens? Well, the only thing available to them, they need to first list the interfaces so they can see what they have on their host, and then they can select. So that's the very first event that we will cover. And that means action list, right? That's the action for our list button. Well, what happens? We call this method list interfaces, and then we're going to enable the select button, set enable true, and we're going to request focus on the text field. Just makes it more convenient for them. So they don't have to click with the mouse. They can just type the number in from the 10 key, the number pad, and go on their way. So list interfaces is sort of our very first JPCap function that will actually make use of some JPCap features and methods. Alright, so they click the list button, and then what happens when they click the list button? Let's go find list interfaces or list network interfaces. Alright, so this method is static, so we don't have to use an instance or create an instance of JPCaptor, but we just say JPCaptor get device list. And once we do this, we're going to loop through here, and we're simply going to iterate through an array of interfaces. Remember, network interfaces up here was a global array of the network interface class, which is built into Java. And get device list will populate that array, right? It'll return an array of all the network interfaces on the system. And then for the whole length of the array, we're just going to go through and we're going to list all of these attributes of each of those network interfaces: the name, description, data link name and description, MAC address, IP address, subnet, broadcast, and so forth. And I commented these out just to show you that there's two ways you could do this. You could either explicitly select an array by element, or it would do the same thing if I commented this out and I uncommented this. I could simply use it like a collection. I could just code my for loop this way and use it like a collection. So you could do that either way. I'm just trying to show you more than one way of doing something. But here I'm just explicitly selecting the first element in my array. And again, I notice I have to make use of a temporary array here, and that's on, in this case, this is getting the array, the octets of my IP address from the selected interface. So from this selected element from my array of network interface class objects, I'm assigning, each of the string portion or the octet portion of the IP address to, in this case here, network interface address, or an array of network interface address objects. And then doing that, I can pull out the address, subnet, and broadcast. And if you don't like that, or if that seems confusing or something, then again, you instead of doing this, you could do this. You could use a for loop here. All right. So either way, you can choose. Don't want to do both, but you can choose one or the other. And that's how list network interfaces works. So I'm going to run the interface again, and let's look at what happens next. Again, disabled, I click list. Notice it lists all my interfaces. And request focus, the cursor is blinking now. I can just type 4. And then what's the next thing I need to do? Well, I have to click the select button. When I do that, it selects the interface and enables the other buttons. So let's see what happens there. Let's look at the event code for the select button. And remember that was action select based on the method to my madness. And what does that do? That simply calls the function choose interface. Well, what does choose interface do? Choose interface is going to simply, in this case, get the text, whatever they type in, and we're going to convert it to an integer or parse it. Now, I probably should try and catch a number format exception here in case I type in banana or some weird, but I'm trying to keep this short and simple. So, there's plenty of room for improvement here. There's plenty of room for some bulletproofing. But hopefully they type in a number and not some text. Otherwise, like I said, just try and catch a number format exception and set it to be 0, the first element or something. But anyway, we need to make sure that it's valid in the range, right? So it has to be greater than -1 because it starts at 0. And it must be less than the counter, off by 1. So if it's, 5, 0 through 4. We don't want to allow them to select interface 23 if there is no interface 23. Okay, so again, you want to think about maybe some bulletproofing there. And then in this case, we're going to set index to be temp, which was the number. And we're going to call enable buttons, which just takes care of enabling all the other buttons here. Right, just set enabled true. And then otherwise, we'll say, hey, that was outside the range. You can't do that. All right, and again, just to show you how that works, if I do this, I'll go over here and show you. I'll list the interfaces, and I'll try something outside the range. 4 was my last one, so if I try to select it outside of range, number of interfaces is 0 through 4. So it just lets me know there, and then I can select 4, and my buttons are enabled, and I'm ready to go. Well, what's the next thing? Well, the next event is what? They're going to click on capture, because they want to capture some traffic. So let's see how that works. So let's go and see the event code for the capture button when they click it. Just clears the text in the text area, it sets our Boolean capture state to be true, and it goes and calls the method capture packets. And here's where we get to use, again, some JPCap classes and methods. So let's take a look at capture packets. When we call capture packets, it builds a new instance of our PacketPirate capture thread. And remember that this object here is simply it's basically a derivative of a swing worker thread. I mean, not derived in inheritance, but I pretty much followed the swing worker thread example from the Sun Microsystems website, or I guess now the Oracle website. So in this case, it's got a construct and a finished method, and I need to do it this way because I'm using a graphical interface. And if I didn't do it this way, the problem is that if I try to run everything in the same thread, my interface would lock up. The user wouldn't be able to interact with the interface, and they wouldn't really see anything until I was done capturing. So to get the text area to update and refresh, and to make it so they can click stop and interact with the GUI while the capturing is going on, it needs to be started or launched inside of this threaded process here. I can't just do it without using this this class here, this class of object. So I'm making use of JPCap inside of a swing worker thread object, and that's this class PacketPirate capture thread. All right, Captain. And I'll show you the code for it. It's just a swing worker class object. Like I said, I'll scroll through it very slowly. And you can download examples like this off of Sun Microsystems, or I guess Oracle's website. But I'll go through it real slow, so if you want to use it or code it, you can just pause and use that code if you want to. But you should be able to find plenty of examples of that online. Alright, so that's all that class does, but you need this class first, and then once you have it, then you can start your capturing as a threaded process. And unless you're doing a console app, I mean, if you're using a GUI, you need to do it in maybe a similar fashion. Alright, so in the construct method, I'm just going to say now capturing on whatever interface they selected, which remember was stored in index. Always this should be inside of try and catch when you're using JPCaptor and JPCap objects. So I'm going to call open device, and I'm going to open the selected device from my array of network interface objects. Okay, and in this case this is the maximum to capture at once. There's a few arguments here, but and then I just created a loop here, a while true loop, and I'm using my Boolean capture state. So I can turn it on and off, set it to be true or false. And based on that becomes sort of the sentinel value of breaking out of this loop. And there's several different ways to do this. Process packet and loop packet work pretty much the same interchangeably. I've tried it with both, and I left them in here and commented them out so you could see. Now get packet would just get one single packet, which is not what I want. I want to keep capturing until they click stop, but if for some reason you needed to do that, then you would call get packet. So I threw that in there, but it's commented out. It's not doing anything. Look, essentially this is all that's happening right there. And process packet will respond to the timeout, and loop packet will not. It's up to you what you choose to use, but alright, so this is the method I'm using. Alright, so until this becomes false, remember it was set to true, until it becomes false, this will happen. And this is how many packets I'm going to capture. Well, I could use -1 and make that infinite, but I'm just going to capture 1. And the reason is because the stop method was deprecated on thread objects, so I'm going to use this Boolean to control the state. Whether or not I'm capturing. That way the player can interact, I'm used to game program. That way the user can interact with the GUI and stop the capturing when they want to. Okay, and then when we're done, we're going to go ahead and close our JPCaptor object, cap, remember, and again, look at our globals up here. JPCaptor cap, these are our globals, okay. And let me go back down to capture packets. And then if anything goes wrong in our try block, we need to catch an exception. So there's our catch block, and then we're just going to return 0. We have to return an object from the construct. And then the finished method is simply this.interrupt. And then finally, basically the swing worker object starts itself. Alright, so captain, which is an instance of PacketPirate capture thread, just starts itself, the start method on the thread. And then why don't we go ahead and cover the stop code, and then we'll test it. We'll see how it works. Alright, so that's what happens when they click capture. And then when they click stop, the Boolean, which was set to true, is now set to false. So remember, that's the sentinel value. It'll fall out of the while true loop. And we're simply going to call the finished method. So again, if I go to capture packets, this becomes false. So that means this will stop when I click stop. And then this will happen. I just call this.interrupt on the threaded object. So let's see how that works. Alright, we'll run it. We'll go through the process up to capturing. We'll list. Go ahead, select capture. Now I'm capturing packets on interface 4. In this case, it's network interface. This is on the network here. And then I'll click stop, and that will interrupt the process. Alright? You can see here's my captured traffic. The only other items on the interface, about and help, those are pretty basic there. It's just a string message and fires off a JOption pane, just giving them sort of a help system for help. And about just displays the program name, and let's see, we've covered about, capture, we've covered disable and enable. The radio buttons, it just changes to text in the field. We've covered exit, or actually we haven't. Let's look at that. Exit. remember that we call setVisibleTrue to get the JFrame to display. Well, when they click the exit button, we're going to set visible false, which will cause it to stop being displayed, and then we're going to call the dispose method so it'll clean up memory and just clean up, any objects that were consuming memory will then be recovered via garbage collection and kind of tidy things up a bit. So that's just the code for the exit button. Okay, so let's help about. We've covered all the buttons, other than we still need filter and info. We've already covered list and load and save. We've covered everything else. So load and save and filter and info are what we need to cover. Alright, the info button is pretty straightforward. It just builds a new instance of PacketPirate network info. And this doesn't even use JPCap, okay? All this does is, this is just some plain old Java code, and again, this is from previous videos where we were looking at the network interface class object, how to use it and how to get different attributes of it. And that's all this is. So it's just a JFrame builds a GUI, and in the same fashion that we built our main window with, and we just go through, and for displaying the interface info, we're just getting, we're using methods or attributes to get different pieces of information on the selected interface, and they can go through all the interfaces. And I'm not gonna. This video is already going to be way too long, I think, so I'm not gonna go through this in detail. But if you need to go through this in detail, there are a few videos that we did just before this that explain how this works. We use the same code in other projects and things. This is just sort of to give information about the interfaces on the system. So if you want to see how that works, again, we'll run it. And here, and here, and here, and about, right? Just a message dialog, JApp message dialog. And info here, we'll pop this up. We can go through and select different interfaces and just get information on those interfaces. Okay, there's my IP. The one 13 is the one my IP. The next important, piece of event code, I guess, would be if they click the filter button. All right, and so action be filter. This is the event code here. That action event is detected, and if they have, we want to make sure that the filter button is checked to enable, and we'll apply this. Otherwise, if it's not enabled, then we're going to say, hey, filtering is disabled. That means we're just capturing all packets. Okay, so, but if it is enabled, all right, and all this is in try and catch because we're using our JPCaptor object here, the set filter method, so it has to be in try and catch. But if it is enabled, then we're going to go through and let's see which radio button is checked or selected. If the RB port special button is selected, then we're going to get whatever they type in, whatever port number they type in the text field. And we're going to append it to this string here and pass that in, and we'll filter on that port. Otherwise, if it's HTTP, it'll be port 80, SSL 443, FTP 21, and so forth. I won't quote them all, but just going all the way down, IMAP. Oops, that should be DNS, right? Just copy and paste, and I got into trouble there. Yeah, but DNS, NetBIOS, Samba. Basically, all of these different ports will, it'll change the filter and the port number as a string using the method setFilter on our JPCap, our JPCaptor object here, cap. Remember up at globals cap. All right, so we want to do this when we're capturing. And let's see how that works. All right, we'll go ahead and we'll run it. So run PacketPirate GUI here. Okay, and we're going to list, and we're going to select interface 4. And I'm going to go ahead and I want to specify, I'm going to enable filtering. And I'm going to specify like port 80. All right. And so I'm going to go ahead and start capturing. And I'm going to turn on the filter here, and I'll just make some web traffic. I'll go here and go here. I don't know who Jessica Beal is or whatever, but all right. So notice I'm filtering here on port 80. And the only thing left for us is load and save. And so we have to create a file before we can load it. So let's look at save first. And that just calls the method save capture data. And load just calls the method load capture data. So we'll take a look at those. And then that's pretty much it. So save capture data. It's just basic I/O file access, Java file access, and there's other videos dealing with that. But we're going to make a new file object called calling it captureData.txt, a new file output stream object, and a print stream object, and we're just going to take all of the text that happens to be in that text area, whatever packet data we've captured and is being displayed in that text area. We're just going to get it, put it in the string, and we're going to write that string to a file and close it, and that's it. And load capture data is just going to do the opposite. Alright, it's just going to, in this case, instantiate or build a file input stream object. Of course, the file has to have the same name, an input stream reader, and a buffered reader. And we just need a simple while true loop here to read until we get to the end of the file, right? As long as read's not equal to -1, until we get to the end of the file. And we're just going to take this string and accumulate, line by line. We'll read line by line into the string capture data. We'll close our file objects and input stream reader, file input stream, and then when we're all done, we're just going to set the text area to the value of that string that we built up here when we read it. Okay, and so again, to see how that works, if we run it, I'm going to go here, and I'm going to go here and list the interfaces, select the interface, start capturing. And obviously you could do a lot more with this. You could use a JFile chooser or something, get fancier. But all right, I'm going to stop capturing here, and I'm going to take this. I'm going to save it. Data saved successfully. There's our J option pane, and just to show the file, let me go look at PacketPirate here. Packet capture, PacketPirate. There. All right, and here's our text file that got created. You can see there's all the captured data from our text area. Alright, and then if I were going to load it, just to show you a blank screen, I'll close the project. I'm going to rerun it inside of NetBeans. And then if I were to load the data, there it is loaded in that text area. Alright, so that kind of covers all of the buttons and all the events, and hopefully just some of the basics of how JPCap works.